Hello, the purpose of this video is to give people an opportunity who missed the 3-2 notes a chance to copy them down, or to give the people that maybe didn't write fast enough an opportunity to finish up their notes. Okay, so remember, all class notes need to be in Cornell note style, which means the question goes on the left, the answer goes on the right. Please make sure to number them. Please make sure to start your numbering with number 7. These notes are going 7 through 19. So if you are typing them, it's going to be 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It's going to be 13 rows and 2 columns. All right. Here we go. 3-2 is about feeding relationships and energy flow within ecosystems. All of the energy in ecosystems starts with the sun. Again, remember, if me speaking while you're writing or while you're typing is annoying, or you just simply don't want to hear me, you can turn the volume down. And what I will do when I'm getting ready to go to the next slide is I'll do this, so you know when to pause it if you're still writing or typing. All right, so as I said, sunlight is where all the energy starts. If we did not have sunlight to run the reaction of photosynthesis, there would be no complex life on this planet. Sunlight allows for photosynthesis to occur. Water vapor, carbon dioxide get taken out of the atmosphere. The photons in sunlight make the reaction happen. We get glucose, which is the base of all food chains. And we get oxygen, which is a byproduct, and complex organisms need oxygen for cell respiration to get energy for their cells. Not all organisms get their energy from the sun. There are some organisms called chemotrophs that actually they are still, I guess, considered producers, but chemotrophs can get their energy from inorganic chemical compounds. They can actually dissolve rock, dissolve minerals that are in dirt, and get their energy. And chem stands for chemical, capital E stands for energy. And again, I'm not going to make this video long enough for people to write everything down. Obviously, if I'm going too fast, all you need to do is pause the video. I'm about ready to hop ahead to number 9. Lots and lots of vocabulary in section 3-2. Whenever you see the word troph, think energy, think feeding. Autotrophs get their energy automatically. Those are producers that can get their energy from the sun. They pull carbon dioxide, water vapor out of the atmosphere. This includes plants, some algae, some bacteria. Pretty much anything that is green is an autotroph and a producer. Producer is kind of a synonymous word for autotroph. Organisms that make their own food. All right, getting ready to hop ahead to number 10. More vocab, lots of vocab. Photosynthesis, the process that makes life possible on this planet. Autotrophs use light energy, take carbon dioxide, water vapor, turn into oxygen, energy-rich carbohydrates. We're talking about glucose. Plants use cell respiration to get energy for their cells, so they're going to burn some of that glucose in the presence of oxygen to get energy for their cells. And the leftover glucose gets stored in their tissues, and that is the glucose that omnivores and herbivores end up eating when there's a feeding relationship. All right, consumers, those are organisms that cannot get their energy from the environment. They must feed on other organisms. So autotrophs, producers, they're kind of synonymous. They kind of mean the same thing. Whenever you see troph, think energy. Okay, so autotroph, they get their energy automatically. Heterotroph, they have to get their energy from others in feeding relationships. Producers and consumers really are terms that we use to talk about food chains and food webs. But a consumer organism that cannot get their energy directly from the environment, they must rely on others to feed on them and get that energy. All right, here we go. On to number 11. Different types of heterotrophs. There are 3. Herbivores eat only plants. So if you are a vegetarian, well, I guess if you are a vegan, technically, you're an herbivore. Carnivores eat only animals. So we're talking like apex predators, wolves, eagles, sharks, things like that. Humans are not carnivores unless you eat only meat, cheese, and things, eggs. But if that is all you ate, you would probably have a heart attack pretty quick. Lots of fats in those things. Most humans are omnivores, meaning they eat both plants and animals. Omni is Latin for all. Detritivore, they feed on dead matter. Decomposers and detritivores are kind of synonymous. We kind of use those terms interchangeably. Decomposers, like bacteria and fungi, break down organic matter. And I apologize in advance if I do any yawning. It's been a long week. It's Friday evening. And right after this, I'm turning on the World Series. Go Tampa Bay Rays. I hate the Dodgers. Not a Giants fan. I hate them too, but I hate the Dodgers worse. It's pretty much because they win way too much. Nothing I would like to see more than them to lose another World Series. We'll see what happens. All right. I think they are the better team, but I think the Tampa Bay Rays have a better bullpen. So if the Rays can get the lead, and if they have that lead after 6 innings or 7 innings, I forget which inning it is, they're almost unstoppable. All right, getting ready to hop ahead. Okay, energy for life comes from, if you're not sure, take a look back at number 7. I really encourage you guys not to fast forward past this stuff. Use this time to practice with your notes. Remember, every minute you spend practicing with this content is a minute you don't have to spend studying for the test when we get there. You're right, it comes from the sun. All right, a little bit of vocab for you. Sorry about that. Let me do this. Oops. Sorry, I thought I had this formatted correctly. All right. Never mind. This is an absolute catastrophe. Let's just get back to where I was. CANNOT space. Oh, we should be good. Sorry. This is how I wanted it to look. My bad. That was rough. Okay, now you should be able to see everything. There we go. Okay. All right. So if you're not sure about these, take a look at number 9 and 10. All right. So autotroph, C, organisms that can capture energy from sunlight. Oh, let's see. 2 is A, produces organisms that can make their own food. 3, B, organisms that need to get their energy elsewhere. And heterotroph, organisms that cannot make their own food. Yeah. Okay. Moving on. Okay, these should be a little bit easier. Take a look at number 11 if you're not sure. All right, so herbivore, C, they eat plants. Carnivore, A, eats animals. Omnivore, B, eats both plants and animals. Detritivore, I always get these mixed up. E, plant and animal matter and other dead matter. Decomposer, D, breaks down organic matter. All right, here we go. How does energy flow through living systems? Through feeding relationships, through eating and being eaten. The eaters are the predators. The eaten are the prey. You might have a hard time going, wow, that patch of grass, that's prey. Well, technically, when we're talking about prey, we're talking about like things that can move, animals. But if we're being realistic, anything that's eaten is prey, animal or plant. Anything that does the eating is a predator. Not, predator usually like refers to some sort of a skill or speed or intelligence. A cow munching on grass, kind of hard to think of it as a predator, but technically that's what it is. All right. Okay, how does energy flow through an ecosystem? One way. Uni, U-N-I, directionally, means one way. That's because the energy always goes from the prey to the predator, not the other way around. So one direction from the sun to the producer, one direction from the producer to the consumer. And I'm not talking about the boy band. Actually, most of you guys are probably a little young for One Direction. They were the rage probably 8-9 years ago. So the reason why it's One Direction, or no, beg your pardon, let me back it up. The reason why in a food chain or a food web, the arrows always go, usually they're up, is because it shows the path of the energy transfer. Okay, so you always will have the arrow pointing from the producer to the consumer, not the other way around. And remember, inorganic, we're talking about compounds that are not part of living things. Organic, organism, organic chemistry. So those are molecules and compounds that are found in living things. Inorganic, we're talking about like the compounds that make up rocks or minerals or water. It's not living. Even though water is found in living things, it is not an organic compound. Getting ready to hop ahead to number 14. More vocabulary. Oh my gosh. All right, food chain, series of steps. Organisms transfer energy by eating and being eaten. Food web. That's basically a whole bunch of food chains, much more complex, that show all of the feeding relationships in an ecosystem. And the food webs for terrestrial on land are much different than the food webs for marine or oceanic. Typically oceanic, the food webs, you'll have organisms that are feeding at multiple trophic levels. And I'm sorry, we haven't hit what a trophic level is, but it's because it's a lot easier for organisms to get around in the ocean. Therefore, usually there are a lot more types of food for predators in a given area. Terrestrial, it's a lot harder for organisms to get around. You got to walk or you got to fly and you got to expend a lot more energy. Also, ocean temperatures are pretty consistent. So there aren't like a whole lot of organisms that specialize for one layer of the ocean because terrestrial is exposed to the atmosphere. There are cold areas, there are warm areas, and that kind of allows organisms to specialize, and that kind of decreases the overall interaction capability, if you will. So food webs link all the food chains in ecosystems together. All right, getting ready to hop ahead to number 15. Yes, even more vocabulary. I know. All right, so here's that term, trophic level. Remember, troph, we're talking about energy. We're talking about energy transfer. We're talking about feeding relationships. So when you have a food web, you do that from the bottom up, okay? Bottom is always the producers. Trophic level 1 is always going to be the producer level, the bottom level. So you count from the bottom up, all right? For your homework assignment, the food web diagram, that's going to have 4 trophic levels: producer, primary consumer, secondary consumer, tertiary consumer. Tertiary is a fancy word for third, okay? What was I going to say? Totally lost my train of thought. Oh, yeah. A lot of people get mixed up because on the food web diagram, you have to label the producer level, and then it's the primary consumer, secondary consumer, and the tertiary consumer. The tertiary consumer, the third level consumer, is actually going to be trophic level 4, okay, because you start at the producer level. So some kids get a little confused. They're like, oh, 3 and 4 and 2 and 3 and 1 and 2. No, we're just talking about the consumers, okay? The trophic level and the consumer number do not have to match. And of course, organisms that are feeding on lower trophic levels, they get their energy from the level below it. And that level gets the energy from that level below it. So if we're talking about a human eating a pig, okay, so that would be human would be the secondary consumer, okay? The pig, they're going to eat grain or grass. So they are going to be the primary consumer. Humans would be the secondary consumer. So we're getting our energy from the pig. The pig got its energy from the grain. So technically, we're getting our energy from the grain one step removed. All right, getting ready to hop ahead to number 16. Okay, like I said before, marine food chains, food webs are typically more complex. So let's assume that there are no squid available. If a shark had an opportunity to eat some small fish and it could do it easily, small fish usually are pretty fast, so that might not be worth the shark's energy expenditure. But it's very possible that the shark could feed on the small fish, okay, if they're there. So, especially in marine food chains and food webs, you have organisms that feed at multiple trophic levels. Okay. Plankton, there are many photosynthetic plankton. Zoo is a Latin root for animal. So these are animal-like plankton, and the way that they are animal-like is the fact that they actually feed on things. Okay, so there's regular plankton, okay, which obviously they're going to be producers, okay, if they're photosynthetic. And then they would be at the trophic level 1, at the producer level, but these plankton actually feed on a lower level, so these are going to be considered consumers. And you can notice they're not green. You can notice here, it's kind of hard to see, but this algae is kind of green. So they're photosynthetic. So trophic level 1, trophic level 2, trophic level 3, trophic level 4, trophic level 5. Producer level, primary consumer, secondary consumer, tertiary, meaning third, and quaternary, meaning fourth level consumer. All right, getting ready to hop ahead to number 17. Okay, energy flows through living systems through, you might want to take a look back at number 12. Yeah, feeding relationships. Good. How does energy flow through an ecosystem? One direction or both directions? If you can't remember, you might want to take a look back at number 13. Yeah, one direction, unidirectional. A little matching for, oh goodness, I did it again. Hold on a second. Killing me, Paulus. Killing me. Mm-hmm. And we're just gonna do this. Oh, great! My numbering is now off. Hello. Sorry, almost finished. Man, what a mess. What a mess. Okay, this should be 3. All right, now we should be good. Ta-da! All right. So if you're not sure, you might want to take a look at number 14 and number 15. All right, you got it. So food chain, series of steps where organisms eat and are being eaten. 2, food web, network of all of an ecosystem's food chains. And trophic level, B, each step in each food chain or a food web. Boy, that was painful. All right, let's finish these things up. So how's the energy in an ecosystem shown? We use an energy pyramid, kind of like a food web. Even a food web doesn't have to be a pyramid, but many of them are. They'll have like a single apex predator that feeds on the consumers below it. But an energy pyramid really makes sense because you have the level with the most energy represents a larger level. So pyramid, small at the top, large at the bottom. And the reason why apex predators and predators at the top have to eat more than lower levels is because they don't get as much energy. As you can tell, there's less energy at the top. My hands are really, really sore. I'm building the foundation for a deck on the front of my house. Lots of lifting of concrete, mixing of concrete, lifting the blocks, digging the holes for the blocks, leveling the blocks. My hands are screaming. I've been working on that for, it'll be a week and a week. Today's the 7th day I've been doing that. Almost finished. Tomorrow I will be cementing in the last of the pier blocks. Like you care. Paulus, could you just go to number 18? Yes, going to number 18. All right, here was what it looks like. So energy pyramid and the amounts. Only part of the energy in one trophic level is passed on to the next level, and it's about 10%. So let's make these numbers, ignore these numbers here. I mean, the percentages totally make sense, but let's assume that this is 10,000 calories worth of energy, okay? 10% of 10,000 is 1,000, so the first consumer level would have 1,000 calories. The second consumer level would have 100 calories. And the third consumer level would have 10 calories. Okay, so the easiest way to remember that is you just simply chop off a 0 from this level to this level to this level, and this level to this level. So this is an energy pyramid. That energy is lost as metabolic heat. So the temperature that organisms have, that temperature escapes to the atmosphere. Metabolic heat is heat that is produced by cell respiration. Our bodies digesting food in the presence of oxygen produces ATP, energy, for our cells. Also produces carbon dioxide, exhaling carbon dioxide, and water vapor. I don't know if you can see that my glasses are fogged up. Now they're not anymore. Okay. And energy, heat energy. Okay. Total amount of living tissue within a given trophic level is referred to as biomass. Bio-living, mass, tissue, stuff that makes up living things. Maybe not a bad idea, because you get to use your notes on the test to draw a quick pyramid or a triangle, okay? Maybe insert some amounts here. So the example I gave you was 10,000 calories, 1,000 calories, 100 calories, 10 calories. Just an example of how you chop off a 0 when you go to each of the next levels. And obviously, if this organism is only getting 10 calories from a feeding relationship, they're going to have to eat a whole lot of those things to get the energy that they need. Organisms down here do not need to eat as much food because they are getting more of the available energy if you feed on lower trophic levels. All right, getting ready to hop ahead. This is it for the notes, but I'd like you guys to stick around and do the check for understanding slides, and there are also multiple choice questions at the very end, and sometimes those questions make their way to the test. Not a bad idea to see those, and some of you guys actually write them down, which is not a bad idea either. Don't need to do that, but some of you guys do a little bit extra to make sure you're ready. Okay, a blank is used to represent the amount of energy in an ecosystem. I don't know, you might want to take a look at, where am I? Oh, yeah, you're going to want to take a look at number 17. Yeah, it's called an energy pyramid, not a diagram. A pyramid, really, you do need that picture of big at the bottom, small at the top, okay? About how much energy is transferred from one trophic level to the next. If you can't remember, take a look at number 18. Yeah, it's 10%. Nice job. Oh my gosh. Actually, I think that's the entire question. Yes, I got lucky. The total amount of living tissue in a trophic level is defined as, take a look at number 19 if you're not sure. We're talking biomass. Okay. All right, the main source of energy for life on Earth is, if you're not sure, you might want to take a look back at number 7. Everything starts with the sun. Here comes the sun. Do-do-do-do. It's one of my favorite Beatles tunes, especially in the morning with a cup of coffee. Organisms that feed on plant and animal remains and other dead matter. Remember, the two terms are kind of synonymous. They're kind of interchangeable. Only one of them's up there, so that should eliminate any confusion. If you're not sure, you might want to take a look at number 11. Yeah, detritivore. All right. How does a food web differ from a food chain? Well, if you're not sure, you might want to take a look back at number 14. This is where the two definitions are. Yeah. B, a food web links many food chains together, or a food web has many food chains. You can't say the opposite. Food chains do not have many food webs. So it's B. Last one. The amount of energy represented in each trophic level of consumers in an energy pyramid is about, if you're not sure, take a look at number 18. You got it. 10% of the level below it. All right, ladies and gentlemen, that is it for the 3-2 class notes. Thanks for being here. Make sure to please turn these in on time. A little bit late's okay, as long as they're completely done. A lot late, you're going to lose some points. Have a nice one. Be safe. Stay healthy.